All right. Hello, my name is Rodney Cummings. I work for Keysight. I'm also vice chair of the IEEE group that handles 1588, which we've discussed previously. Right there. So I'm going to talk a little bit, I guess to introduce it, about a new project that's going on in the IEEE group called P1588.1. The P just stands for project. So this is not a published standard. It's something that's just starting out and is in work. But it's potentially relevant to OCP, so thought I'd give a presentation on it. It's called Client-Server PTP, potentially applicable in data centers, like I said. So to start out a little bit, I thought I'd talk a little bit about open source and standards. Basically, what is the relationship between those two, when there is a relationship, you know, when there's a topic. This is kind of an exaggerated view to just kind of make a point, namely that open source is very flexible, very innovative, very fast changing. That's kind of one of the benefits of it. So I'm drawing an analogy to clay. Obviously, it's more solid than that, but again, exaggerated. And standards, a lot of people view those more as like granite, basically very stable, very foundational, slow changing, but understandably slow changing. Slow changing can be a benefit, meaning I invest in it and I know it's going to be around for a while. And there's kind of a relationship between the two on many topics. So one of the things that's kind of come up lately, in particular for this project I'm talking about, is it okay for an open source project to violate a standard? Meaning, here's an open source project kind of related to this standard, but maybe it doesn't follow all the rules of the standard. So recently I've been having discussions with people and I've been advocating for yes to the answer to that question. What often happens is that when that happens, like when somebody has a new idea that's not in the standard, a lot of times they'll try to argue, well, I'm still complying with the standard because I found this legal language and that legal language, and you get in all this back and forth debate that, to be honest, kind of wastes time. The better approach that I've been advocating is, if you've got a new idea, go ahead and put that in the open source project. See if it works, see if people like it. And if it seems to be successful, then we'll migrate that new idea into the standard and make it compliant, conformant, and following all of the rules. And that's kind of generally been the approach that I've been advocating. So why does that matter? So I'll give a quick overview of how IEEE 1588 works. Basically, as Dan said, this is a protocol to distribute time through a network, like an Ethernet network in a data center. One technique is called multicast. Namely, you've got a server that's providing time, for example, connected to GNSS or LEO. It's communicating and exchanging PTP messages with the nearest switch. That switch communicates and exchanges messages over its ports with the other switches. So it's essentially kind of a multicast kind of scheme. This scheme has the benefit that you're kind of going port by port by port, so you can support any number of clients that need time. But it does require more investment. It's more complicated. The switches have a lot of PTP knowledge and have to implement PTP. You have to figure out the topology. There's some complexities to it. Many industries use this technique, including in-vehicle and industrial automation. But there is an alternative that is also commonly used, and that is unicast. And the idea with unicast is basically you're passing the PTP messages that kind of flow through the switch without the switch having to do too much other than just read timestamp and adjust the timestamp. That goes to a particular client. So it's essentially a single client talking to a single server and exchanging time. And as you can see, for each client you have, there's a different exchange. So again, the pro for unicast is it's simpler, it's quicker, easier to implement. If your network is kind of designed mostly for unicast, like many data center networks are, it's a clean fit. And the con, of course, is every client has their own exchange. So it's not just one exchange throughout the entire network, but if you've got 100 clients, there's 100 exchanges going on. So what is the problem with that? with the current 1588 standards for unicast. Basically, there's a protocol called unicast negotiation that's in the 1588 standard today that essentially you kind of, in the unicast scenario, you negotiate for every message and say, I want this message to server, okay, I'll send you this message. And it's a pretty complicated protocol. It does take network bandwidth per client. There's a fairly complicated set of states that have to be maintained per client by the server. And because there's just more stuff going on, there's more opportunity for bugs, timeouts, and things like that. So with hundreds of clients, which was kind of the original telecom use case when this scheme was created, for a couple of hundred clients, this stuff isn't that big a deal. It works well, it's stable. But when you get to like millions of clients, which a large hyperscale data center might have, it's very burdensome, and it's a bigger problem. So, going all the way back to my previous discussion about open source and standards and so on, there was a new idea. And the new idea was basically to simplify unicast PTP, try to have a single message that goes from the client to the server, and then have a single one or two messages that come back from the server to that client, synchronize time just like you were before, and keep it simpler. And what's more, keep it such that the server doesn't have to maintain state per client, which is kind of a big complexity in the whole thing. There were at least 3 open source projects, not just one, that kind of implemented this new idea. SPTP, which Meta had been working on and advocated in OCP. Flash PTP was another project. And the IETF working group started on an effort to wrap NTP in PTP to improve the performance of NTP. And that project was trying to use this simple technique as well. And that's in one of their open source projects. And of course, Microchip had similar ideas in some of their servers for PTP. So really the bottom line is all of this stuff kind of happened. It was deployed in the field, it was tried, people liked it, and it was generally successful in the open source community. But in the standard itself, it still technically violated the standard. So what did we do? So like I said, the value of the new idea is proven in many projects. There were advocates that kind of, for those different projects that agreed, yes, we would like to standardize this and work it through an official standard. We decided that merging this into the main 1588 document would be too many if-then-else statements that would be confusing in the main document. So the agreement was that we would create a new document, a new standard called 1588.1 that would standardize this concept of a client-server simple interaction. So that's the project that is kind of kicked off formally. Meetings began a couple of months ago, so it's still fairly new. Most of the work is going to be to kind of like merge the best of all those 3 projects. You know, they all have subtle differences in how they do the messaging and so on. We've kind of gotten through phase 1, which is each one of the advocates of those open source projects presents their work, presents why they think theirs is better and so on. We're kind of entering phase 2, which is debating the differences and trying to come up with a document, you know, that basically has an agreement in it. Yeah, some of the differences are how to run PTP and this new client server PTP together in the same network. There are some use cases for that. And also how much to try to simplify things. Is it 2 messages on the return or 1? How much do we try to, you know, optimize things and so on? So one question is, will that standard apply to all data centers? One thing I'd kind of like to be clear about, because this has been kind of a point of confusion, is not necessarily. Some data centers might prefer to just use PTP because there's so much equipment out there and everything else. Maybe they can deal with the complexities that I talked about and it's fine. There's some other data centers that might want to run time distribution as separate cabling and not over Ethernet. That's a thing that happens. So to be clear, this isn't the end-all, be-all for data centers, and nobody's really claiming that. There's still open questions about different use cases and different needs. And actually, yeah, I mentioned here there's a precedent for that. So for example, if you look at automotive in-vehicle use of PTP, there's actually 3 profiles of that, basically 3 ways that it's used. And that's because even within a particular industry, it's kind of common for different companies to have different perspectives and different use cases. It's a normal thing. So really quickly, if I have time, I'd like to talk about kind of a new thing that's trying to kind of address that issue, which is an IEEE industry connection on timing in data centers. So in IEEE, when you don't have a firm idea for a standard, like the 1588.1 project, and you just need a discussion among industry experts, they suggest forming one of these things they call an industry connection. And an industry connection in IEEE is very similar to OCP's work streams and so on. It's basically just a way to encourage discussion and have calls and presentations, things like that. Try to produce a document at some point to capture the ideas. So basically, we've kicked off one of those in IEEE to try to help sort through some of this. When do people need PTP? When do they need client-server PTP? And so on. We decided to actually do that jointly with OCP TAP. So essentially, there'll be a subset of OCP TAP calls that will be jointly held with this IEEE industry connection. And we'll try to just explore what do data centers need in terms of timing. And anybody that has any thoughts or any presentation on that is welcome to share their ideas in that. And like I said, it'll basically be a meeting of OCP TAP and IEEE. So, call to action. If you're interested in the details of 1588.1, what the messages are and so on, welcome to participate. You don't need to be a member of IEEE. It's really just sending an email, getting a registration, attending the meetings. And of course, another call to action, which is maybe more important for this group, is please participate in that industry connection. Share your thoughts about what data centers need for timing, and we'll try to kind of collect all that together. And with that, that's all I had.
Thank you, Rodney.